Hi, I'm Dr. Frank Summers, and welcome to Hubble's Universe Unfiltered. 2008 has been a year of real anticipation around here because these 7 astronauts, the astronauts of Shuttle Mission 125, have been preparing for a shuttle mission to service the Hubble Space Telescope. Over its 18-year lifespan, astronauts have gone up several times to upgrade and repair the Hubble Space Telescope. And this was probably the most ambitious mission to date, a mission that we called Servicing Mission 4. Now, the astronauts have been preparing for it all year long, and here is an image of them in what is called the Neutral Buoyancy Laboratory. Basically, it's a giant swimming pool. And here you have the astronaut on the end of the robotic arm, and they are underwater because the air inside their suit lifts them towards the surface, while the weights around their ankles pull them down. And that makes them sort of float in the water, similar to the way they would float in space. So in the Neutral Buoyancy Laboratory, they can operate pretty much as they would do in space. And here they are practicing all of the servicing maneuvers that they will do on the spacewalks when they go up to Hubble. And in September of this year, we've gotten so far as to have the space shuttle go the long way up to the launch pad. The space shuttle sitting on the launch pad in late September for an October launch. 2 weeks before the launch, and now it's been delayed. It's been delayed till spring of 2009. What happened? I mean, all of this anticipation built up around here, all of the work, and now it's been delayed for 6 months. Well, let me explain it to you. And I'm really going to take a short story and make it a little bit longer, because I'm going to go all the way back to the beginning, just so you understand the full details behind all this. The beginning in this case means 1990. This was the space shuttle launch that carried Hubble into orbit on April 24th, 1990. Now, when I say carried Hubble into orbit, it takes Hubble into what we call a low Earth orbit. So if this is the size of Earth, and this white line right here is the size of Earth's atmosphere. Let me blow that up for you so you can see it more clearly. Okay? Earth is about 6,400 kilometers in radius, and Earth's atmosphere is only about 100 kilometers thick. 1/64th of Earth's radius. So it's a very thin atmosphere. And the space shuttle lifts Hubble up to about 600 kilometers. So Hubble's orbit is about 600 kilometers above Earth's surface. Most people, when they imagine where Hubble is, think of, well, if Earth's here, Hubble's got to be way out here. You can see it really isn't. Hubble is just above Earth's atmosphere, and that's the really important point. For Hubble to get its really clear view of the universe, it just has to get above the atmosphere, so it's several times higher than the atmosphere. If you want proof of this, it's very easy to see in this image of Hubble, taken from the last servicing mission from the shuttle. Here you see Hubble, here you see the curvature of Earth, and you can see Hubble is really close to Earth. And you have to think about it. If you just sort of fill out the size of Earth, look at that small curvature you've got here. If you fill out the size of Earth in your head, you go, wow, Hubble really is just above Earth's atmosphere. And really, that's all it needs to be in order to get above the blurring effects of the atmosphere and get such sharp, clear pictures of the universe. So, being so close and being able to be visited by the space shuttle is a really good thing for Hubble. Hubble was designed to be serviced by the space shuttle. It turned out to be really important back in 1993 when we had our first servicing mission to Hubble because, well, you remember there was that small flaw in the mirror? Yeah, well, we were able to go up, service Hubble, and fix the problem with the mirror and restore Hubble to its full capabilities. Now, one of the things we did in that first servicing mission was we replaced an instrument called the Wide Field Planetary Camera with the Wide Field Planetary Camera 2. All right, this is Wide Field Planetary Camera 2, and it was on the ground during the time that we figured out that Hubble had a flaw in its mirror. And what we did with PIC 2 is we actually designed it to correct for the flaw. The optics in this instrument were changed so that they would counteract the flaw that was in Hubble's mirror. And so all we really do in this servicing mission was we just pulled out this sort of piano-sized instrument, pulled out Wide Field Planetary Camera 1, and then put in Wide Field Planetary Camera 2. And here again you see the astronaut on the end of the robotic arm doing the spacewalk, this time really in space. So these servicing missions have been invaluable for allowing us to change out the instruments in Hubble. So when Hubble was launched in 1990, it had a complement of 5 instruments. There are 4 instruments here, and each of these instrument boxes is about the size of a telephone booth. And then you've got the radial instrument here, which is sort of hidden by these guys. That's the wide-field planetary camera, and as I said, that's about the size of a piano. During our first servicing mission in 1993, we put in wide-field planetary camera 2, but we also replaced one of these telephone booths, and we put in something we call CoStar, which was basically a pair of glasses. So for the other 3 instruments here, CoStar put in corrective optics to help them adapt to the flaw in the mirror again, as well. So this one had the fix already in it. The CoStar provided the glasses to fix the other 3 instruments. In servicing mission 2 in 1997, we added in a near-infrared camera, a camera that looks in the infrared wavelengths that are a little bit longer than visible light. And we also replaced the spectrograph, put in a new spectrograph. Then in 2002, we put in, called the advanced camera for surveys, another camera into Hubble. And finally, what was planned for 2005 was to put in a 3rd generation of a wide field camera, as well as put in yet another spectrograph. So you can see that over the history of Hubble, every single one of the instruments has been replaced. And you know, I sort of think of this like the computer I had when I was in college. I got my first computer around 1989, and I kept that box for over a decade. And you may say, well, wait a minute, computers changed a lot. Well, computer hardware changed a lot, but I kept the same box. What I did was I pulled out the hard disk and swapped in a new hard disk. I pulled out the CD-ROM and then swapped in a DVD. I even pulled out the whole motherboard and got rid of my 286 processor and replaced it with a 486 processor. And then a few years later, I pulled out that 486 processor, swapped in a Pentium, and so on. The components inside the computer changed over time, but the box was basically the same. And each time I upgraded the components, it felt like I had a new computer. The same is true with Hubble. Basically, the basics of Hubble don't change. The tube, the mirror, all of the basic electronics, they don't need to change. What we're changing are the science instruments on the back end. And each time we make changes, we get upgraded to the new technology, and you know what? It really does feel like we have a brand new telescope. Now, I said this was slated for 2005. Obviously, it didn't happen in 2005. Unfortunately, in 2003, we had the Columbia tragedy, and the Space Shuttle fleet was grounded for 2.5 years. The Space Shuttle fleet returned to flight in 2005, and in 2006, this servicing mission was then put back onto the shuttle schedule. And it was turned out that the timing for it was scheduled for 2008. Originally, the idea of delaying this servicing mission until 2008 was really actually quite scary, because the batteries on Hubble were decaying. Now, here are bays 2 and 3 on Hubble. Hubble has all these various doors you can open, and they're called the bays. This is bays 2 and 3. And if you open bay 3, you see on the inside this big black box. These are Hubble's batteries. Now let me note that this is a picture of Hubble in space. This is the real Hubble Space Telescope. This is a mock-up of Hubble on the ground. We have a lot of spare parts and mock-ups and test facilities on the ground. So these are batteries on the ground, not actually the batteries there. But inside bay 3 and bay 2, there are 2 sets of batteries. And batteries have a tendency to wear down over time. Now, some of you may say, wait. Hubble is powered by solar arrays, isn't it? Yes and no. As Hubble does get power from the sun through its solar arrays. But as Hubble orbits Earth, it goes from daytime to nighttime, to daytime to nighttime. Every 97 minutes, Hubble goes through both a day cycle and a night cycle. So it's charging the batteries during the day cycle, and it's discharging the batteries during the night cycle. Over 18 years, Hubble has done 100,000 orbits. That means 100,000 charge and discharge cycles. And if you've got rechargeable batteries at home, you may know that rechargeable batteries tend to lose their maximum power over time. The same is true with Hubble's batteries. And here's a chart to show you sort of the measure of the power in Hubble's batteries over time. And so here is launch in 1990, and you can see the battery charges between 500 and 600 ampere hours, and slowly it starts to degrade. And we got kind of worried in 2002 to 2004 when the ability to maintain a charge started to decrease markedly. And if you extrapolate that, you can see that around about 2008, 2009, it get down to about 100 ampere hours. And this reaches a critical level because Hubble needs enough power just to maintain its basic control systems. And if it doesn't have enough power, we'll have to put Hubble into safe mode until we can go up and service it. Because if it actually runs out of power, the whole satellite could start tumbling, and then that's it, game's over. You can't go up and catch a tumbling satellite. So we were worried that we had to get the servicing mission done before 2008, 2009 in case the batteries were going to continue to drain in this fashion. However, we don't have a backup for the batteries on Hubble, but we do have a duplicate set of batteries here on the ground. This was amazing foresight by NASA because these batteries on the ground were not just the same technology, but they were going through the same charge-discharge cycles as the batteries on Hubble. The 100,000 charge-discharge cycles that the Hubble batteries were going through, well, the engineers were doing the exact same with the batteries on the ground. So you had the same hardware that had been through the same experiences, and so you could then use those as a perfect test bed for trying to figure out how to reverse this decline. So by experimenting with the batteries on the ground, in 2006 they were able to institute new procedures for the batteries, and you can see that the ability to maintain a charge in the batteries actually started to increase back up. So the delay to 2008 time frame was not as worrisome as one would have originally expected. This teaches us two things: that having hardware on the ground that you can work with is a really good thing, and delaying the mission to 2008 didn't really hurt us in terms of worrying about the basic systems of Hubble. Now, this brings us up to the current time. This is the shot from September 20th, 2008, and the shuttle is on the launch pad. And actually, one thing I didn't show you last time is that there was a second shuttle on the launch pad. One of the reasons we had to push the Hubble mission back, it took a while to get the Hubble mission back into the shuttle schedule, is that they wanted to have a backup. If a shuttle goes up to the International Space Station, well, if there's a problem with the shuttle, the astronauts can stay at the space station until we can send up another shuttle to make sure everything's okay. Hubble is an entirely different orbit from the space station, so you don't have that safe harbor. And so the safety precaution in the case of the mission to Hubble was to have a second shuttle on the launch pad waiting. So here it is, the end of September, 2 weeks before launch. We got 2 shuttles on the launch pad, and then what happens? Well, in NASA speak, we had an anomaly. All right? And the anomaly happened with this piece of equipment, the Science Instrument Control and Data Handler, which is quite a mouthful. So I'm just going to call it the data handler. This piece of hardware on Hubble suffered an anomaly. Now, I can't tell you exactly what went wrong because the data about what happened in that anomaly, well, this is the data handler. Well, the data was on here, so we couldn't immediately figure out what was going on with it. But this does actually have a backup. The electronics in it has a side A and a side B. So if we had to guess what happened in the anomaly, you'd say, all right, it was a short in the electronics. All right, and so you could move from side A to side B. Let me show you that a little bit in a block diagram. Okay, Hubble has a main computer, which, by the way, is actually just a 486. And that's not really the computer that it launched with. The 486 computer was swapped in one of the servicing missions. So you may think your computer's slow. Well, Hubble, the state of the art for Hubble is still a 486 computer. All right, and that main computer talks to the instruments that we talked about earlier, all of those instruments in the back of the telescope, and it talks to the SIC and DH, or the data handler as I'm calling it. And what happens is the data that is taken by these instruments goes through the data handler, which then does all the formatting and gets the data ready to send to the ground. Well, the anomaly on the data handler knocked out the side A of its electronics. And this has happened on other instruments on Hubble. You know, the side A goes out, and so we switch over to side B. But this happened 2 weeks before the servicing mission was to go. And we could, of course, activate side B, and of course that's exactly what we will do. But when you've only got 2 weeks to do that, you got to say, can you really go with a shuttle mission and not be sure that this whole system is going to work? Because the side A of the electronics had been working for 18 years straight. We'd never even touched side B. Side B hadn't been used. And so when you have that short of a time, the decision was relatively quickly made that, all right, we're going to delay the servicing mission. That's the first part of the delay. Okay? And so then we tried to reactivate side B. All right, and we had the main computer had to go over to the instruments, pull them out of their safe mode and say, okay, do you have a working interface to side B through to the data handler? Then it put those guys back into safe mode, came over here, tried to turn on the data handler and say, okay, talk to it. Our first attempt at reactivating Hubble, basically rebooting Hubble's science observing systems, encountered two problems. One turned out to be a software problem where we just uploaded the wrong command. And the other one, well, I guess I'd characterize it as a timing problem. From what I understand, a power supply was expected to reach its maximum voltage in a certain amount of time, but didn't get there in time. And we moved on to other things before the power supply was at full voltage. And so by changing the timing of it, you know, we should have been able to bring it up. But having these problems while trying to activate side B reinforced the idea that now this data handler, having only one channel open, was a single point of failure for Hubble. And so while NASA had been leaning this way the whole time, the decision was officially made that we really wanted to replace the data handler in our next servicing mission. So the next servicing mission has been delayed till April or May, late spring of 2009, so that we have time to take the data handler that's on the ground. Again, we have flight spares, we have identical hardware on the ground. We're going to take the 18-year-old hardware on the ground, we're going to qualify it for space, and we're going to fly it on the next servicing mission and replace the data handler. The really good thing about that is actually that the data handler was meant to be replaced. It's only got 4 bolts that need to be taken off, pull the data handler off, put the new one on, and the astronauts describe it as a really easy thing. And compared to some of the other things we'll be attempting in Servicing Mission 4, it really is much simpler. So, having learned the lessons from the first try, we then did a second try at activating the science instruments, and the second try was successful. The instruments are now operational, and they're working through the side B electronics of the data handler, and we're getting data back from Hubble. The proof is not, of course, in the electronics. The proof for Hubble is, of course, in the pictures. And here is the first image to come down from Hubble after reactivating after our anomalies of the last month. And we call this picture a perfect 10. And what you're supposed to see is this galaxy here on the left forms the 1, and the galaxy on the right here forms the 0, and we've got this 10 in space, and it's also supposed to indicate that Hubble is back to being a perfect 10 and producing science again. I know, it's a little bit corny. But what really is going on here in terms of the science is that what you've got here are 2 interacting galaxies. Together these galaxies are called ARP-147. They are the 147th galaxy pair in ARP's catalog of interacting galaxies. Actually, he called them peculiar galaxies. And these two look really kind of peculiar. This one over here on the left, you can see it's got this really sort of thin ring and then this sort of bulgy thing, and they got that bright blue stuff around it that looks like it's star formation and stuff. And the center part of it and the external part of it don't appear to be connected. And that really is kind of funky. And then over here you've got this ring galaxy. But when you look at it closely, we sort of question, is it really a ring galaxy? I mean, the only way you'd get some sort of ring like this is if you had a collision and you sort of like a pebble going into the water creates a ripple, a circular ripple. Well, you could create a circular ripple of all this star formation. We see this in a galaxy called the Cartwheel Galaxy. But we looked at it really closely and said, you know what? Maybe it's not a ring. Maybe, in fact, it's a corkscrew. Because you've got to trace it. You follow it from here around to here, right? This is sort of the core of the galaxy. You can see the colors here are slightly different. And then you've got all this star formation going along here, and it comes back here, and this might actually pass behind this region and then finish off with this tail over here. So instead of being a circle, what you might have is a corkscrew like this, where it corkscrews around, and then you're looking down the pipe of the corkscrew, and it ends up looking like a ring. We do know that these two galaxies are relatively close in space, and you see sort of, this stuff pulling off over here, and it looks like they're having an interaction. But I gotta say, this is a really peculiar pair. It's really interesting to see the interactions. But what it really signals is that Hubble is back together and it is doing science, okay? And we won't be getting to service it anytime soon. It will be about 6 months before we send up the next servicing mission. And when we do the next servicing mission, we got a whole slew of things that are going to happen in that servicing mission, including replacing the new data handler, as I said. So there's a ton of stuff that's going to happen next spring, and I don't want to go into it today. I'll tell you about that in another episode of Hubble's Universe Unfiltered. Stay tuned. Astronauts have gone up several times to upgrade and repair the Hubble Space Telescope. And this was probably the most ambitious mission to date, a mission that we called Servicing Mission 4. Now, the astronauts have been preparing for it all year long, and here is an image of them in what is called the Neutral Buoyancy Laboratory. Basically, it's a giant swimming pool. And here you have the astronaut on the end of the robotic arm, and they are underwater because the air inside their suit lifts them towards the surface, while the weights around their ankles Hi, I'm Dr. Frank Summers, and welcome to Hubble's Universe Unfiltered. 2008 has been a year of real anticipation around here, because these 7 astronauts, the astronauts of Shuttle Mission 125, have been preparing for a shuttle mission to service the Hubble Space Telescope. Over its 18-year lifespan, pull them down, and that makes them sort of float in the water, similar to the way they would float in space. So in the Neutral Buoyancy Laboratory, they can operate pretty much as they would do in space. And here they are practicing all of the servicing maneuvers that they will do on the spacewalks when they go up to Hubble. And in September of this year, we've gotten so far as to have the space shuttle go the long way up to the launch pad. The space shuttle sitting on the launch pad in late September for an October launch. 290. Now, when I say carried Hubble into orbit, it takes Hubble into what we call a low Earth orbit. So if this is the size of Earth, and this white line right here is the size of Earth's atmosphere. Let me blow that up for you so you can see it more clearly. Okay? Earth is about 6,400 kilometers in radius, and Earth's atmosphere is only about 100 kilometers thick. 1/64th of Earth's radius. So it's a very thin atmosphere. And the space shuttle lifts Hubble up to about 600 kilometers. So weeks before the launch, and now it's been delayed. It's been delayed till spring of 2009. What happened? I mean, all of this anticipation built up around here, all of the work, and now it's been delayed for 6 months. Well, let me explain it to you. And I'm really going to take a short story and make it a little bit longer, because I'm going to go all the way back to the beginning, just so you understand the full details behind all this. The beginning in this case means 1990. This was the space shuttle launch that carried Hubble into orbit on April 24th, 1990.